So let's start right into motion. So when we are discussing general motion, there are three main characteristics that we have to keep in mind. We have to keep in mind the direction. So like kind of like north, south, east, west, left, right, whatever we're kind of talking about, positive, negative. We also have to keep in mind the location, but not just any location, but the location at a specific point in time. And then the last thing is about the speed, right? Or how fast something is going. Okay, so those are the three main characteristics for general motion. And what also is important is that motion is all relative. Okay, so what that means is movement of that object is all in relation to a specific frame of reference. And what we mean by frame of reference is a group of objects that are not moving compared to one another. All right, so as I sit at this desk right now, I have a pen in front of me. To my point of view or to my frame of reference, that pen is not moving. So I would describe it as having no motion whatsoever. Okay, but if I was to change my frame of reference to somewhere like, I don't know, like the sun, because the earth is moving and I'm on the sun, my frame of reference has changed. Now that pen is moving really, really fast, like 30 kilometers per second, which is crazy. Okay, so what we can say here is that when we are looking at certain types of movement, it's all about the frame of reference of the observer. And what we mean about that is like the outside observer frame, the inside passenger frame, a leader or a follower frame. So again, the description of how a car might move is going to be different for someone sitting inside the car to someone that's sitting outside of the car and seeing it past them, right? It doesn't mean that the description of the motion is wrong. It just means, hey, it's different for each person or that observer. Okay, so again, we're talking about three main characteristics of motion: distance, direction, all that stuff. And then we also have to keep in mind the frame of reference. All right, so our first kind of key phrase here is distance. And distance, we're going to be talking about distance, and we're going to be talking about displacement. And so distance is the length of the path between 2 points. Okay, so what this means is that we measure it in meters, but a better way to kind of describe distance is how much ground that object has actually covered. Okay, so as I sit right now, I'm covering no distance whatsoever. But if I was to walk 5 meters in towards like the left direction, then my distance that I covered from point A to point B would be 5 meters. If I was to walk 5 meters to the left and then walk back to my seat 5 meters, then my total distance would be 10 meters, that total path taken. Okay. And so another great example is like this little rectangle example. So in this example, you're the little red dot, and that little red dot is going east 4 meters, then it's going south 2 meters, then it's going west 4 meters, and then it's going north 2 meters, right? So the total distance covered would be 4 plus 2 plus 4 plus 2, right? So that entire distance or that entire path taken. While displacement is a bit different. Okay, so displacement is all about the change in position. And what we mean by position, again, it's all relative, but it's from one point to another. Okay, so like your starting to ending point. And again, a kind of a better way to describe this is how far out of place the object is from its original position. Again, we measure this in meters. But if we kind of look at this example, I love this image so much because what it does is it looks at the starting and it looks at the ending position. And the total path taken is the distance, right? And you can see that distance is in that purple, where the green is the displacement, where we are physically measuring the difference between that change in position from point A to point B. What is the difference between them? Where the entire path taken is going to be the distance. Okay, but the change in position is going to be displacement. So we've probably all been on roller coasters before, and if you've ever stepped onto a roller coaster, right, like you're standing in line, you're waiting to get on that seat, and then you're kind of at that like kind of gated area where you're about to step into the ride. And what you might notice about a roller coaster is that the starting and the ending are the exact same position, right? So your displacement is actually a big old goose egg. It is 0 because you are starting and ending at your exact same position. But your distance, well, that's going to be whatever the distance you cover in that roller coaster, right? So going through all those loops, going over those hills, all of that crazy stuff. So what this example is showing us is that because we are starting and ending at the exact same position, then our displacement is 0 meters because we haven't changed our position. But our distance is the entire path taken of that roller coaster, right? So it's going to be very different. And we're going to talk about scalar and vector quantities in just a second, but let's jump into an example. All right, so again, this is kind of just a visual example now of the example that I kind of already did verbally, right? So we have a person that's staying at a starting position, which we can see with the red dot, and they are moving 5 meters. So the total distance covered is 5 meters, but the displacement is also 5 meters because their change in position is from that starting to end, which is 5 meters. Now, what's a bit different is if this person was to walk that 5 meters and then come back, then because they started and ended at the exact same position, then it would be 0 because they're starting and ending at the exact same position, so their displacement would be 0. And this can also be seen in the vertical as well, like if you've ever been on an elevator. Again, your change in floors would be like the entire path taken, but if you're starting and ending at the exact same floor, then your displacement would be 0, or it might even be different, like you're starting from like the ground floor and going up all the way to the 13th floor, then your displacement would be 13. Whatever your change in position would be. Right. About scalar versus vector quantities. And if you've ever seen the amazing movie that is Despicable Me, then you know this character very well. This is Vector. And the reason why his name is Vector is because he commits crime with both direction and magnitude. And that is going to help you remember vector quantities. Okay, so what a scalar quantity is something that only has magnitude attached to it. Okay, so this would be like traveling 5 meters. We have no idea in which direction, right? It could be to the left, it could be right, it could be up, it could be down. We have no idea. Where a vector quantity has both magnitude and direction. Okay, magnitude or the strength, so that 5 meters, and then a direction attached, north. Right, 5 meters north. So that would be an example of a vector quantity. So what you might notice is that something like distance is scalar, where something like displacement is going to be a vector quantity, or there's going to be a direction that has to be attached to displacement. So what you might notice on your formula sheets is that distance is represented with a lowercase d. And so when you see that little triangle symbol, it is not an Illuminati symbol, it is actually our delta symbol. And this delta symbol actually stands for the change in. So what this little phrase is saying right here is that this is the change in distance. Okay, and our displacement is represented with an x. Okay, and that x is represents displacement. Again, they're both measured in meters, but we can also solve for the change in x, or our change in position. Okay. So if we have this example, if a person walks 4 meters east, then 2 meters south, then 4 meters west, then 2 meters north, what is their total distance covered? And then what is their total displacement? So please go ahead and answer that now.